Hi, welcome back to our YouTube page. This is Mark from Northcom Technologies. Today's video we're going to be focusing on our new Aeroflex 3920 and the companion software for the Motorola XTL, APX, and Moto Turbo Autotest. As many of you know, Motorola is gold standard when you send your radio to the repair depot for repair, alignment, or flashing, is that radio is going to be realigned and calibrated with the Aeroflex 3920. This unit is so much the gold standard in the industry that Motorola actually offers courses on how to use this machine for people who are qualified to service their radios. On the bench today you can see the Aeroflex 3920 as well as a 110 watt APX 7500 single band VHF radio. The orange cables you may not recognize. These are high quality phase stable RF cables made by Megaphase. And the black device in between those two things is a 20 dB coaxial attenuator. Whenever you test a high power radio in a service monitor, it's recommended that you use some sort of a coaxial attenuator in order to save the internal dummy load of the machine. In today's video, we're not only going to show you how Autotest and Tune works, but how our Autotest and Tune procedure is better than those being offered by many of our competitors. Not least of which, Motorola recommends that you use an external time base when calibrating and aligning the Motorola APX. If I move over just a minute, on our work area you can see that we use a Fluke 910R atomic clock. This clock is disciplined with the rubidium internal standard as well as an external GPS signal. It is one of the most accurate timepieces that you can buy today outside of a cesium clock or a hydrogen clock. Now before we begin the test, there's a couple of connections that we had to make to the 3920. The first one is the RF connection, which is the orange cable that goes into the transmit and receive port. And the second connection is actually a power connection. That's the red cable that goes into the current shunt. This cable is necessary for all the APX Autotest and alignment current measurements. So I'm going to zoom out and bring us into a tight shot of the main screen, and I'll take us into Autotest. Now for the purposes of this video, I'm showing you the Aeroflex 3920's display on a larger Dell monitor. It's just so that we can see it together. And I'm also going to be controlling the unit remotely with a mouse. You can control the unit from the regular keypad on the machine or through a VNC connection on your laptop computer. But to begin, I'm going to right click. We're going to go over to Autotest 2. And that's going to bring the machine over to our testing formats. Now while this loads up, it's important to know that you don't need Autotest to align any radio on the Aeroflex 3920. It's a regular full-size service monitor. As a matter of fact, it's probably one of the best on the market. It's just that Autotest and Tune allows you to have data that you can show to your customer, that you can have on paper format, and it also does a radio in around 8 to 15 minutes, whereas a person would usually take between 35 and 40 minutes per unit. The first thing we're going to do is we're going to go to Motorola APX Autotest. The Astro 25 is for the XTL series radios. The Moto Turbo radios and the other NXDN and DMR radios are on a separate screen. On this screen we can select all the tests that we want. The standard tests are PA bias, reference oscillator, receiver front end, broadband power, etc. Depending on the kind of radio, whether it's single band or dual band, or in the case of the APX 8000 tri-band, the unit will automatically select the appropriate tests. You can see that this machine also has the Phase 2 TX and RX test portions. As you may or may not be aware, there is now another phase of P25. There's Phase 1, which is 12.5 kHz channel spacing, and now there is also Phase 2, which is 6.25 kHz channel spacing. They're very similar in the way they emit energy, but for the purposes of this video, we're not going to explain exactly what goes on. But the first step before we begin our auto test, we're going to go to Edit Specs and Cable Loss. And we're going to select our radio, and it's already up on the screen, APX 7500 VHF, model number M30KT. You can see here there's a whole list of different radios, depending on what model you need. But we have an M30KT, so we'll stay with that. Now, we want to select our cable loss. We can go manual, cable 1, or cable 2. I'm going to select cable 2, and the reason we're going to do that is because I've already swept both the short cable and the long orange cable connecting the radio, as well as the 20 dB load resistor. So cable 2 is what is measured after the 2 test cables and the load resistor is measured by the 3920. This way, when we select cable 2 and the 3920 measures the radio's power output, it will compensate for the loss in the cable and the loss in the load resistor. We're going to return. We're going to have cable 2 selected. An APX 7500 is being tested, model M30KT, and we're going to save. We'll return, and now we're going to go to Align and Test. Align and Test is going to take the radio and it's going to calibrate all the soft pot values. Test and Align is going to test the radio to see what its current alignment status is, and only align those things that it finds to be out of specification. But in this case, we don't know anything about this radio. We want to go through it once. We're just going to go to Test and Align. Now the radio is connected to 3920 through a USB port and a Motorola programming cable. There's no rib involved, and there's also no computer involved. The Aeroflex 3920 is nothing more than a software-defined radio, so it is a computer itself. This screen tells us to connect the current shunt, which you've already seen in the prior first half of the video, and also the AC 2509 coaxial attenuator is recommended to protect the internal dummy load of the 3920. We're going to continue. And it'll tell us to connect the cable to the VHF radio port. Transmit, receive. We're going to continue. Now that we can see all the radio information that's up there, the tests are going to begin. So that you understand what's going on, the first test started was PA bias, and it's reading what's called SPVs, and those are the soft pot values. And it's going to read a soft pot value from the beginning, show you what the beginning measurement was, and then show you what the end measurement was. And the Aeroflex 3920's predetermined internal memory has values that are targeted for this soft pot alignment. It just did a reference oscillator. It tuned the radio to 0 Hz frequency error as disciplined by the Fluke 910R into the back of the 3920. Next is broadband power alignment, which, as you probably already know, is how we align the radio's power output. And these are all the same tests that you might do manually in APX tuner, or if it was an XTL, an XTS tuner. But for any of you who have done any of these radios by hand, know just getting this far might already take you 5 or 10 minutes. As it goes to the power characterization screen, you can see that it's setting the low power and the high power settings, and it's also measuring the amp draw and current. Now it's going to move on to setting the TX current limit. Of course, all this is done because we have that current shunt installed. Alright, we're coming up towards the ends of the testing for this APX 7500 110 watt mobile radio. We're now on the P25 received bit error rate test, and this is how the Aeroflex 3920 will actually test the radio's receiver. It does it in one shot. Most of us are used to testing a receiver in analog mode. Maybe we might look for 12 dB synad at 0.2 or 2.5 microvolts. But in the case of these digital radios, the Aeroflex wants to check the bit error rate in P25, and by doing that, it's going to inject a signal at minus 116 dBm. which, as you know, is probably a bit stronger than we normally would use, but it's what's specified by Motorola. We can actually test these radios at a lower level by changing the value in the 3920. However, in the case of this test, we left everything at the factory setting. And by testing bit error rate, of course, we know the receiver is working within specification both analog and in digital. Because if it didn't hear in digital, it wouldn't hear in analog, and vice versa. Now it's going to move over to the Phase 2 tests. There's a few people out there selling test and tune with the 3920, but there are not that many who are doing Phase 2. And one of the reasons is because Phase 2 is so new, and this option is quite expensive. And Phase 2 testing is one of the areas where having the external time base comes in real handy. Phase 2, as I said before, is 6.25 kilohertz channel spacing. 12.5 kilohertz channel spacing is tight. 6.25 kilohertz channel spacing is very tight, and it requires real frequency accuracy and real frequency reproducibility. And that's what you have when you use an external atomic clock. And again, there are those people out there who might grab an old HP GPS time clock and say that they have an external time base, but the Fluke 910R is the only atomic clock on the market in its price point that can offer you printed valid data stating the frequency error of that day at that time. The result of this is that when we give our customers printouts of what the radio did in Autotest, we can also provide that day's frequency error, and it provides a circle of traceability. So we've reached the end of the testing procedure, and as we can see, this APX 7500 radio has completed all tests successfully. Everything from PA bias alignment to reference oscillator, broadband power, or P25 phase 1 and 2. At the end of our test, we can scroll back up through all the results and take a look at anything we might have been particularly interested in. But all of these values here will be printed out for the customer at the end of each radio's process. Now, in order to complete this testing sequence, we're going to press continue, and we'll go back to the main APX 7000 alignment screen, and we'll visually see in green boxes that everything that we needed to know about is a pass. This particular radio does not allow us to tune the RX front end filter. The test set knew that and wouldn't attempt to do it. We can then go and view our results, and I can copy them to a USB drive, or I can simply go onto the network and download them directly off of 3920's memory. But for now, I'm going to back out of this. Alright, so now we're back with the same Aeroflex 3920, but this time we're going to test and align a Motorola XTS 5000R UHF portable radio. In order to complete this test, we're going to use the same megaphase phase stable cable into the transmit receive port of the 3920. That is adapted over to the 5000R's SMA with a Unidapt kit, and we're using the Motorola factory USB cable. For those of you who were wondering, the 3920 is a USB based device now, and it will not accept test cables that use ribs or non-ribless cables. So if you're trying to use this test set with something that requires a rib, it's not going to work. But now I'm going to go in, I'm going to zoom back into the main screen that we were looking at before, and we'll get acquainted with how we complete this test. The screen that's already up here is the configuration screen. Let me just go back. This is the main screen for the Autotest 2 alignment suite for the Astro 25 radios. That includes all the XTS and XTL radios, with the exception of the Astro Spectras and the XTS 3000s. Some of those radios can also be tested in the line, but at these days we aren't really seeing any of those anymore. In order to get this radio set up and ready to go, we're going to go to Edit Specs and Cable Loss, and we want to select our radio. Problem is, I don't know what kind of radio this is. Why? Because the battery's on it and I don't feel like taking it off. And those of you who notice will excuse me for not using the battery eliminator, but that's currently being used in another radio at this point, so for the purposes of this demo, we'll just use a freshly charged battery. But what I want to do is I want to have the radio tell the Aeroflex what it is. So I'm going to back out, and I'm just going to go to test. And we can already see the model number comes up. It's an H18QD. And now it's going to try to find the radio's IP address, which it did. And we'll wait for the main screen to reset. And we can see that this is an H18QD. So let me abort the test. And I'm going to go to Edit Specs and Cable Loss, and we can see that the Aeroflex already pulled up the right radio. XTS 5000R UHF range 1 5 watt H18Q. But it also set the cable loss to manual, and I know that this megaphase cable swept on cable loss 1 in this fashion. So in order to null the cable's losses out, we're going to go from manual to cable 1. And you'll remember earlier we went over to cable 2 because we were in fact using a large coaxial load resistor. So I'm going to go ahead and save this. I'm going to return, and then we're going to do an align and test. Now, as in the first radio, the Motorola APX 7500, we also did align and test because we didn't want to know what the radio was doing before. We were just concerned with getting it calibrated, so we're going to go ahead and do it now. So the first test, as you can already see on the screen, is going to be the reference oscillator alignment. It's looking for a frequency error of less than 100 Hertz. And it's changing the soft pot values as displayed on the screen, and it narrows them down. We're going to end up with, I believe, 24 Hertz frequency error. Minus 29. And with a final frequency error of 23 Hertz. Now, the APX 7500 did not allow us to do a front-end filter alignment, but this radio does, and we can see that the Aeroflex is measuring the RSSI and checking for a passing value. This radio is aligning just fine. The other thing you may notice about the XTS and XTL series radios is they're a little bit quicker to align. They have less soft pot values that need to be gone through. Now, the reason you cannot use a battery when aligning these radios, and again, I know that I am now for the purposes of this demonstration, is because right now we're doing a broadband power alignment, and we could see that we're at 5.22 watts, 5.24, etc. Problem, of course, is a battery is going to get tired fairly quickly, and we need to use an external battery connection so that we know that the measurements that we're making are in fact accurate. We would not want to use a weak battery and have the Aeroflex turn up the power output higher than it should be. Now, the passing or failing output that you're going to end up getting once your radio is tested and aligned with the 3920 in our shop is going to be exactly what you see on the screen, just in the same way that you would get the results from the APX series radio. And what's nice about these results is it's going to include the serial number of the Aeroflex unit that aligned your machine, as well as the serial number of the radio that was aligned. So there is never any question of when the radio was aligned, by what machine, and what the accuracies of the test were. Now, I have noticed that there are some people out there who are using the new Aeroflex 8800 communications test set to run these auto tests. That's a great little test set, but it's really made for portable field use. We may pick one up here, then again we may not, probably opt for another 3920. The 3920 is made for bench work. It's really not made to go out in the field like the 8800. And because of that, it's scientifically a little bit more accurate, and it's more feature-filled. And so again, the industry standard by Motorola's own internal standards is to use the Aeroflex 3920 to tune and align Motorola radios. So you can see that we're now on to the P25 transmit test, and shortly after that it's going to be the P25 bit error receive tests. And again, the XTS and XTL radios are both analog and digital radios, so it's necessary to test them in their P25 modes. And again, just like the APX series radio, the Aeroflex 3920 is going to check the ultimate receive sensitivity of this portable radio by injecting a signal at minus 116 dBm and looking for a predetermined bit error rate below a certain amount, which in the case of all Motorola radios tends to be around less than 5%. Well, as with the APX series radios, we've reached the end of our alignment procedure for this XTS 5000R, and as you can see, we've achieved all passing results in about 8 minutes and 52 seconds. So we're going to go ahead, we're going to press the continue button to leave this screen and return to the home screen. And like the APX subscribers, we can see that all these radios show up with green boxes for all those tests that have passed, and in the case of radios that need further adjustment, red boxes for those areas that failed. And of course, this is one of our shop radios. We know it's good, so this radio passed all tests. Now we can go to view results and we can copy this to our USB, or we can just upload them off our internal network to our one of our computers here in the shop, and those results get emailed to all our customers. Finally, for the end of this video, we're going to back out of the screen and we're just going to show you a couple of the features of the analog side of the Aeroflex 3920 for those of you who are curious. So I'm just going to go to analog duplex. The system is going to back out of the Autotest and tune script. For those of you who have never gotten to work with 3920, I'll give you a brief overview. It's broken down into 4 tiles. A generate tile for generating your signals, an analyzer tile for receiving your signals, a metering tile for measuring such things as deviation, frequency error, or offset, and in the case of this tile right now, we've chosen modulation distortion. We can sort of do a sanity check on this machine to see how it's working by generating a 1 kilohertz signal at 152.5 megahertz into itself. So we're going to generate into the same port that we're receiving from. So that concludes our testing demonstration of the Motorola APX and XTL and XTS series subscriber radios on the Aeroflex 3920 and 3920B. As you can see from all the testing data and the measurements that we take here at Northcom, when you receive your radio back, you can be assured with 100% certainty that these radios are being returned to you to factory specification and working in the way they were intended to work from the factory. And again, the Aeroflex 3920, in conjunction with our testing processes, are the way that Motorola recommends their radios be serviced, both in the field and at the service depot. Just for those of you who are curious and never seen the Aeroflex 3920 in person, this last screen we're just performing a test of the service monitor itself. We're generating a signal into itself and checking some audio deviation. 3920 is a full-featured machine, and for those of you who are wondering if we can do radios such as the Pro Series CDM, network equipment like the Motorola GTR, Quantar, Quantro, and MTR 2000, we can absolutely align those radios to the same degree of precision that the Autotest will align your devices automatically. Just be aware that anybody who tells you that devices such as the Pro Series CDM, HTs, Quantars, Quantros, or MTR 2000s, if they claim that they're going to auto-test and align those devices on the Aeroflex 3920, that is an untrue statement. Aeroflex never developed scripts for those devices. However, those devices can be calibrated on this machine the same way that you calibrate any pre-auto test device on any service monitor that's commercially available. For those of you who are running MTR 3000s, Moto Turbo radios, and lower tier Moto Turbo repeaters, we can align those repeaters in Autotest and provide you results. If you have any questions or you want to follow up with an inquiry for repair or calibration of your devices, please check out our website at repeatercables.com. Again, that's repeatercables.com. Check out our eBay page. The call sign is MDAN160. Or feel free to respond to this YouTube video and we'll try to get back to you as fast as we can. Thanks for watching and we'll talk to you soon.